All right, so welcome back, everybody. My name is Pedro Cenci Dal Castel, and today's lecture, or the last lecture of the day, is using CompuCell using the Python API. So this is full Python implementation of anything you learned so far without using Twedit and without using Player. We'll go over why this could be relevant and what are the things that you can gain and what are the things you lose from adopting the Python API approach. So these are the kinds of things you will be able to do. So first, you can import CC3D. Import CC3D allows you to use everything you saw so far in terms of plugins and steppables in any kind of Python script you have. So you can use CompuCell3D just as you use, for example, Matplotlib, PyTorch, Tellurium, etc. You're going to import CompuCell3D like a normal Python package. You can execute your simulation using the command line in a very simple way, just by typing Python and then the name of the simulation or the path to the simulation, press enter, and it's going to execute via your terminal. And you can also, inside a Python script, you can execute your simulation by running a command such as os.system. And then, for example, f Python CC3D simulation, the path to your simulation. And you can even give it, you can change the name of the simulation programmatically. In this case, you could have a parameter p equals a certain value p. So if you have this line in a Python script, it's going to execute this command, and this could be your CC3D simulation. Just reminding that the workshop is live streamed, recorded, and distributed, and we are going to start. So what is the objective of this lecture? My objective with this lecture is that you know where to find sources for building pure Python simulations. Because some of the things are not trivial, and we cannot in 1 hour and a half cover everything, all the aspects. So I'm going to point you to the correct source and to the good practices that I do, even though I am not a specialist in this and I am just a beginner in this Python API thing, and I am not a developer. I can use it and I will tell you what are the things I do so that I can use it robustly. So without having to email a ton of people asking for help and being able to do all sorts of things on my own. I will, one of my objectives is so that you understand what is the basic setup and also the advantages and disadvantages. This is what allows you to become a magician using CC3D in the sense that you can do all sorts of things imaginable if you are using the Python API. I wouldn't say that all these things imaginable would be impossible via Twedit and Player, but they are more complicated because you would be trying to integrate things with more components, such as Twedit and Player, rather than just a Python package. So if you're trying to integrate Twedit and Player with other Python packages, it might be harder than if you are just relying on pure Python scripting. So what are the advantages and disadvantages? So the main disadvantages is that you lose almost everything that Twedit and Player provide. There is built-in visualization from Player, for example. Um, for example, you can still see the lattice in the 3D, rotate, You can do all sorts of things, like you can visualize fields, set scales, uh, but there are problems sometimes, and especially in this latest version 4.9, there are things that are not working properly. Sometimes there are crashes, and I'm experiencing crashes now that I updated to 4.9 that I did not experience before. And if I want to use 4.9, I have to do some workarounds. Sometimes these crashes do not report any error, so it's almost impossible for a beginner like me or a beginner like you to fix these issues without the help of an expert or a someone that is experienced in developing Python packages and C++ uh, software as well, because CC3D is a C++ software. In the end, what ends up happening is that I write my own visualization. Which is annoying. Sometimes there are certain things I can't do. For example, I don't know how to draw borders, and I tried doing that before, but I failed, and it's like it's too much work to bother. So there are certain disadvantages in this sense, but there are visualization things. For example, if you want to make your cells transparent, or if you want to change the opacity of cells that you cannot do in player anyways. So if you have a complicated 3D simulation and you want your cells to have some opacity so that you can see through the cells, but still see some of the cell, you will end up having to write your own visualization anyways. And there are certain things that I like to overlay. For example, oh, I would like to have the field visualization over the cell lattice. To a player doesn't do that. So it's much easier to write your own visualization for these kinds of things. And now with Codex, Copilot, Claude, you just write a prompt and it does everything for you using Matplotlib, using using other kinds of packages if you want. So I don't see that as a restriction. I don't see losing player as a problem because the AI tools are so incredibly powerful that you can do almost everything that player does and more. But of course, it's less user friendly. You lose Twedit Wizard, so it's harder to build a simulation from scratch. Even using AI assistance, sometimes it doesn't build the way you want. It's not as clean. It's not as short. Sometimes it's a little bit. Um, okay, there is a bug in the chat. I'm going to look at the bugs later. Okay, I'll talk a little bit for like 20 to 30 minutes, and then we will take a look at executing the simulation. All right. But what do you gain instead? So you gain one, full integration with other Python packages. You can do everything imaginable. So let's say you have a molecular dynamics simulation that you want to integrate with Python, with CC3D seamlessly, like without having to develop a new plugin, for example, for CompuCell3D, which requires C++ expertise. You can build a full Python simulation and do the integration there. We had 1 or 2 years ago a student in the hackathon that integrated a sophisticated PDE solver, a dedicated PDE solver in Python called Phoenix with CompuCell, and he did that using the Python API, not Twedit. Okay. And also, it's easier to modularize the simulation. What is modularizing? Modularizing is transforming your simulation basically into a function, something that you can call. You you give inputs to this function, and it returns you an output. And with that, you can integrate your simulation into, for example, optimization scripts, calibration scripts, or local sensitivity analysis scripts without having to write your own because all of those already exist in Python. There are Python packages for all of those things. So if you have your simulation as a function, it opens the doors for all already implemented Python packages that have hundreds and hundreds of people developing. So develop much faster than tools like Twedit and Player. So you're benefiting from the community, this giant Python community worldwide, much more than if you restrict yourself to Twedit and Player. I'm going to talk about one of the main gains. Sorry. Yeah. So before that, because I never remember the order of my slides, for that I usually recommend installing CompuCell3D via Conda environment because it's less prone to errors, but it works the same. It works fine with the binary install. It's not a problem. But when for example, let's say you already have a Conda environment with PyTorch and all the all the neural network stuff you have, and you just want to have your simulation there, you're like your Conda environment is already set up, it's perfect. You can do a Conda installation. It's easier than trying to bridge between two different Conda installs, one from the binary and the other one where you have your PyTorch and your other stuff, or having to install all of your packages in the CompuCell Conda environment because you installed it using binaries. And also in clusters, so if you want to run your simulation in a cluster, uh, so what is a cluster? A cluster is a computer somewhere with hundreds of CPUs. So you can run hundreds of simulations in parallel. So you launch a ton of simulations if you are doing parameter exploration, and then you wake up the other day and you have all your results there. This is the cluster. In a cluster, you will most likely install CC3D using Conda. So yeah. Just a recommendation. Another recommendation, use a dedicated Python IDE. You can use others. You can use Google Colab to edit things. You can use online tools. You can use Jupyter Notebook. You can use Idle. You can use Notepad. But I recommend, and I'm even going to remove Spider from my suggestions. I'm not gonna call Spider a dedicated IDE. I don't think it is anymore. I'm going to keep just these two. PyCharm from JetBrains and VSCode. VSCode, I think it's Microsoft. My recommendation is VSCode simply because it's the one I'm using now, and it's free access. So like you just anyone can use like I don't know if there is a paid version. I haven't looked into it, but PyCharm is less accessible in this sense. It's much more restrictive. But people use PyCharm as well, and it's probably as good as VS Code. So it's just a matter of preference. Because I use VS Code, I'm going to recommend VS Code. And because I don't understand PyCharm and I'm not using PyCharm, I cannot help you if you are using PyCharm. If you're using one of these IDEs, you have to run the IDE in the environment where CC3D is installed, or you select, you go in your, like in the configurations, the Python interpreter configurations, and you set as the Python interpreter the Python installation of your CompuCell3D installation. I'm going to show you now. Doesn't mean you have to do it now. We're going to do it later. I just want to show you what it means. Here I have VS Code. I'm going to press Ctrl Shift P. And then there is this option here, Python select interpreter. If it's not showing, you just type interpreter and then you click here. It's going to give you a bunch of options. These are all your different Conda environments. So I can select base. I have another one that I call PLT. I have my CC3D compile environment, and I have my CC3D 490, which is the same version of CompuCell that you have installed. So I would select CC3D 490, or in your case, it will be a different name. Okay, this is a custom name. It doesn't show it like that for you. But you just have to make sure that the path here is the path to the Python executable in your CC3D installation. Yeah, Control Shift P, and if you're on Mac, it's Command Shift P. I am going to go back to this, so don't worry yet. If you do not have an IDE setup, you still can use Jupyter Notebook, and I'm going to show you how to launch Jupyter Notebook. You have Jupyter Notebook already. If you install CC3D, you have Jupyter Notebook. This is important. So you don't need to install anything for this lecture. You can just use Jupyter Notebook. It's already there. But if you happen to have VS Code, you're good to go. Okay? Then I will help you to use VS Code. So what are the benefits of using a modern Python IDE, such as VS Code or PyCharm? One of the cool things is that you have AI assistance in real time. And what is that? What is AI assistance in real time? This is one example. I type a comment here. My comment is SLP with NS1 always off column. And then I press enter. And because it sees the thing here on top, it sees the pattern of the thing I wrote before, it suggests something. I didn't write this. It's suggesting me to autocomplete all this chunk here, which by the way is correct. And I can just press tab and it's going to autocomplete for me. Okay. I just typed a comment and it suggests all of this. This is extremely powerful. I can write, for example, a comment saying, oh, this is a function doing blah, 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 and I press enter and it suggests the entire function for me, which sometimes even understands CompuCell3D language. So it's going to use for cell in self dot cell list by type and I don't know with all the appropriate inputs and outputs. Cell dot target volume equals it understands that. Okay. So this is called inline ghost suggestions. Let's see another one. You can just query your AI tool of preference. Through IU I have Codex and I installed an extension in VS Code that has Codex. Codex is from ChatGPT, by the way. So it's an AI from ChatGPT. It's right there in my, I can also show it for you and I am using, of course, I'm already using it. I have my codex here. I have my code here. And then I can just type something like, let's see what I typed here. I want to append to the pre-existing files. And it says, okay, updated. The runner now appends to the existing files by default. Nice. Okay. So I can do things much faster. So what are the types of things you can ask? You can ask, what does this line do? Okay, you are trying to understand code. Write a function that writes the simulation output to a file. It does that very well. Implement the differential division hypothesis as described in the attached paper. Yes, you can insert a reference. This is the PDF that I'm basing my model on. Based on this PDF, can you implement this hypothesis in my model? And then it's probably going to do a more or less good job, okay, for these more sophisticated queries. But it can fulfill the goal there. So this is an example here. I query rename the parameter narana to narana, and then it gives you a change summary where it says, oh, I changed this file, I changed this file, that file. Okay? And for each one of them, you can opt to keep or to undo the change. And it's also going to point you to the changes line by line. So for example, in this line here, it is suggesting, okay, you want to change this to this. The previous line is here in red. The new line is here in green. And the exact change is highlighted with a lighter color of red and a lighter color of green. And for this individual change, you can opt to keep or undo. And it's going to do that for all changes the AI is suggesting. What else? Whenever you have an object, a Python object, and you type a dot, it's going to open a list of possible attributes and methods. So, for example, a cell in CompuCell has certain attributes and methods. For example, the surface of a cell is an attribute. But, oh, I don't remember how to get the surface of a cell. You press dot, and then there is the list. You can see, oh, surface is an attribute. Oh, I don't remember if the center of mass is an attribute. How do I get the center of mass of a cell? You press a dot, it opens a list, and you check. Did you know that there is an attribute called target cluster surface? You probably didn't. I didn't. I bet the other CC3D users here didn't know that too. But because I press dot and it opens all the list of all methods and attributes, suddenly you discover something new that can be useful for a problem. What else? This is cool. You hover your mouse over a function and it gives you all the documentation of the function. It gives you what are all the parameters that go in and what are all the outputs and examples, if it's a good documentation, examples of usage. So here I have the NumPy function mean. So it just calculates the mean of something. Or you can also press comma. Oh, see? There are two things going on there. You type comma and space and it suggests dtype equals, it's trying to predict what you want to type there. So it's suggesting you, okay, if you just press tab, it's going to autocomplete. Dtype equals np.float64. But it also pops up the documentation for you. So there are two ways to pop up the documentation. You can open parentheses and then it opens the documentation inline, or you can just hover over mean and then it opens the documentation. Mm, yeah, nice. So for example, there is a function of CompuCell that is very weird. It says kill cell or something. And then you hover over the function and then it opens the documentation. Now you know what you have to put in as an argument, what it gives you in return, what exactly it does. Okay? Another one. Let's say you have a function or a method or a variable. You can right click and go to definition. And it's going to lead you to where that function or variable was defined. If it's in another Python file, it's going to give you that, open that Python file for you. So for example, here I have delete maboss from cell. That's the function. I right click, go to definition, and then it goes to the Python file in CompuCell3D. I don't know even how to find this file, by the way. I don't know where this file is. But because I click go to definition and I'm using VS Code, I have the definition of the function where I could, for example, modify it, which is very dangerous, by the way. You shouldn't do that. But you can also just, for example, understand what it does and what it returns, all the things it returns. Especially if the documentation is not so good, which is the case of the functions in CompuCell. Not very complete. All right. Another very good thing. This is one that I love and I use very often. Comparing files. You can have two simulations or two versions of the same simulation, and you launch both and you compare them side by side. VS Code or PyCharm is going to give you a line by line comparison, highlighting exactly where the change is and what are the lines, whatever. And then you can, I didn't put this in the slide, but if you hover your mouse in between the two lines, there is an arrow where you say, okay, apply this change to this other file. And then you can merge two files simultaneously, which is very cool. Is there a plan to make VS Code the main way to write CC3D code in the future? Or is the idea to stay on to edit mostly? So the idea is to stay on to edit mostly, but yeah, that's the answer. And the team is making efforts to expand to edit and make it more useful. So it's up to you to decide. There are some cool stuff in Twedit, like the wizard. The wizard is very cool. But there are some cool stuff as well here in VS Code. It's not impossible to have wizard in VS Code, by the way. Someone could write an extension of VS Code with Twedit's wizard, where you can define your simulation there and it builds your simulation automatically. This is possible, but currently Twedit wizard just works in Twedit, and there are no. I don't know. Yeah, if there is, I don't know, but I would say there is no um, current effort into making wizard part of VS Code as an extension. All right. What else? Full integration with GitHub. So you have a track of all your changes and you can work with your GitHub repository from VS Code. Do you want to launch a version of your simulation from 2 years ago? You just click your GitHub tree and it gives everything to you. And oh, you want to see the differences between the previous version and the current version? You use the file comparison, right? By the way, this screenshot is comparing one previous version of my simulation that I had on GitHub and the current one. So you can commit, pull, push, synchronize, add a file, all sorts of GitHub-y things you want to do. Yeah, as Hayden mentions, the current philosophy behind CC3D development is to make modeling more accessible to people, not rather than like more powerful to people, because most of the modelers we work with, they are not most, yeah, maybe most. They're not like C++ experts and Python experts, you know? So there is a lower barrier of entry for these people if we have something dedicated and something that you can like click here if you want contact plugin, click here if you want a cell to be frozen, click here, you know. It's easier to have that. It's much more easy to instruct people Rather than, okay, we are going to open terminal and do a Conda installation. And VS Code, now let's make sure VS Code pulls Python from, if you don't even know what a terminal is, we lost you. It's very hard to have, for example, a 1 week workshop from zero to modeling without Twedit and player. Yes, the IDEs do not give you the initial code. This is one of the limitations, as Wizard does. Other benefits of using a Python IDE, like VS Code, is you have all the extensions that the community develops. So this random guy here, Josh Johnson, I don't know who he is. He developed this XML tools package for VS Code. So if you're using VS Code and you still have your XML, the XML you were using to edit, you can install this extension and it's going to highlight the XML format and everything and has I don't use XML tools, but it might have very cool stuff for editing and maintaining XML code. One that I will show to you today is the live share. The live share allows you to collaborate in real time with your teammates. You can watch them code with them, branch from their code, work on their file manager, so you can download their files and upload files to them. You can run their code and much more. You can also track them. You don't need to screen share anything. You are in your VS Code with the file of your collaborator there, and you are watching them coding, and you can type something in it simultaneously. So of course you can troll people, but if you have a serious team, they will also troll you, of course, because there is no seriousness ever. All right. What is necessary? So far I gave you recommendations, but now this is really going to be necessary that you access this link over here. GitHub scripts. This is where you are going to pull the syntax for building your simulations. So in this GitHub folder, there is going to be a simulation specification for chemotaxis, simulation specification for cell sorting, and some other stuff that I don't remember. That's where I mainly pull syntax from. And also, because of AI, modern AI tools, you can download this folder and use it as context for the AI and say, please build me a simulation with this, and that plugins. And it's going to understand the patterns of this folder full of scripts, and it's going to write a simulation from scratch for you, most likely working, because these AI tools nowadays are insane. Especially if you have the paid version. I use the paid version and it is insane. Like they can you give the GitHub folder to the AI and ask, okay, build me a simulation with these plugins and these behaviors and these interactions. It does it for you. Is there any need for more people to work on helping to make Twedit more accessible? Yes, there is. I would be interested in that if help is needed on this front. Yeah. So I think I will copy this and paste in the chat. This link is quite important. All right, exercise 1. Let's set up your workspace. It depends on whether you did a conda install or a binary install. If you did a binary install, which I think it's most of you, you have to activate your conda environment. using this command if you are on Windows. Sorry, this command on Mac, this command on Windows. Ah, yeah, I'm sorry. So if you have VS Code, you don't need to activate anything. Okay, if you have VS Code, this is not necessary. But you might still do it because sometimes the VS Code will crash for you, and then so like an independent terminal is usually more stable. Yeah, so we are looking for people to develop Twedit, but also if you want, if you are if you're a fan of VS Code or other things, we could have more extensions there as well. So for the second one, the path is Miniforge. Ah, so they changed to Miniforge. Oh, this is interesting. I did a Conda installation, so I just open my Conda prompt and I type conda activate and the name of the environment like this. This is how I do it. So I don't need to know where Python is installed. If you are in PyCharm or VS Code, I mean PyCharm, I don't know. Don't ask me. But if you are on VS Code, then you have to select the appropriate Python interpreter. In Windows, it's Control Shift P. I'm gonna guess in Mac is Command Shift P, but I'm not sure. Then you press Enter and then you select the Python executable in your CC3D installation. So in my case, this is how it looks like. I type Control P select interpreter, and it gives me these options here. And one of the options is my CC3D installation. But you can also enter a path, and then the path you give is the path to your CompuCell installation folder where python.exe is at. So this would look like something like this. I would go to my CompuCell3D. Here is an old version. Uh, and then where is it? Where's Python? Where is Python? Envs, CC3D. Do I have Python here? Do I have Python here? Oh yeah, I have Python here. Yeah, so that would look like something like this. CC3D and Miniconda 3. Then I would enter path and type this. And then press enter. Oh, it has to contain python.exe. Yeah, and then press enter. If it doesn't recognize it automatically, if it recognizes automatically, it's going to list here. Okay. Let me know in the chat if you are using VS Code and you could select interpreter. Yes or no? And if you are not using VS Code, let me know if you could launch Jupyter Notebook. To open Jupyter Notebook, run the command Jupyter Notebook in your terminal after you activate your Conda environment. Okay, VS Code, yes. So this is what opening Jupyter Notebook would look like if you have a binary install. I would find my activate, sorry, CMD. I would find where my activate is. In the case of Windows, my activate is over here. So I would do, is it bash? No, it's call activate. And it's active. Then I would run Jupyter Notebook. Not recognized. I think this version is too old. So let me use a newer version of CompuCell. After you have your your thing active, CC3D 490. You will type Jupyter Notebook and press enter. And then it launches in your browser like this. Okay, so I have two people. I want to know from the people who's struggling to launch either Jupyter Notebook, VS Code with the Python interpreter. So Raghu, let's take a look here on my screen. Are you on Windows or Mac? On Mac. So you are going to type Command Shift P, and it opens this drop-down menu here. Let me know if you're here. Okay. Now, do you see this option saying Python interpreter? Select interpreter. If you don't see it, type interpreter. And then you select that, and it should open these options here. Are you here? Not exactly these options. These are dependent on the user. So these are my specific environments. In your case, it's going to show something else. Okay, let me know if you're here. Yeah, it could be different in Mac. Let me think. So you don't have this interpreter thing. Could it be an extension? Ah, so let's try something, Raghu. Can you go to your terminal in VS Code, which is down here? And then I want you to do a conda activate here. So to do the conda activate, you're going to type in the case of um, Mac, you are going to type in bash and the path to your CompuCell, which I think people are saying is Miniforge 3 or something. You have to double check in your path to CompuCell, okay? So this will look like something like C slash your user slash CompuCell. It will look like something like this, okay? But you have to make sure that the path is correct. Okay, dot something, dot what? Yeah, activate. Okay. Try running that in your terminal and check if it works. In the meantime, I'm going to continue the lecture. Keep me updated in the chat. Okay. Exercise 2. Check if you can call CC3D from your Python file and run. All right, yeah. So to launch a Jupyter Notebook, you have to activate your conda using either one of these commands, and then you are going to type Jupyter Notebook and press enter. So if you are here, you are going to type Jupyter Notebook and press enter. And you must have your CC3D Conda environment active. And let me know if that's happening. You do not, let me see. Conda call. Oh, oh yeah, slash activate. Oh, Run the oh yeah, so you have it active. Wait, no. Run deactivate Conda. So get out of there. Open your terminal again, and you are going to run. It's supposed to be just that second command you give. Call conda bin slash activate. But something is missing there. I think it's missing activate dot bat or something. Uh, activate activate dot bat maybe. So try that and let me know in the chat. Could you guys do import CC3D and run without errors? If you could do that, you are all set. And if you can do that, your next step, so you can already do the next exercise, is run the sorting demo. This is a Jupyter Notebook. If you launched Jupyter Notebook, you can launch the cell sorting demo in Jupyter Notebook. So download the demo, the cell sorting demo, launch in your VS Code or Jupyter Notebook, and run it. And eventually you should see more or less the things I have here. And this is our final exercise. Okay, so while people, okay, when I run the Steppables class using CC3D and I get to 0 module not found, Matplotlib. Ah, you don't have Matplotlib you have to install Matplotlib. So in your terminal, you will do pip install matplotlib. And if you don't have pip, you're going to do conda install matplotlib without a slash. Yeah, because CompuCell does not contain matplotlib. You have to install it if you don't have. So the suggestion I have to you, Barga, is I will try to solve it while people do this exercise. Are you sure? Because you were typing call, no, activate, but there is a space before call. I wonder if that's the problem. Because if I run something like space conda deactivate, it works. Interesting. So that shouldn't be the problem then. Let me think. Call, it doesn't work. It doesn't activate. Let me take a look at something real quick. Um, I would say open your terminal, navigate to this folder where you have activated.bat, and execute via command line. That would look like this. CMD over here, and then you run activate.bat like this. Try that. Okay? Let me know in the chat. Okay, could you guys run the demo, the Jupyter Notebook demo? I got it to run as IPython and now with no visualizer. And cannot get it to run as Python script. Oh yeah. So this you cannot run the Jupyter Notebook as a Python script. That's correct. Yeah, Jupyter Notebook is a completely different beast. Yes, you run it as a Jupyter Notebook, not as a Python script. You can, of course, copy and paste all the command lines in put it in a single Python file and execute that. So Bargo, if you just press activate, if you just type activate.bat and hit enter, nothing happens. It doesn't show base. Just the activate.bat command doesn't suffice. This is very common. Having to restart the kernel and rerun is common. Barga, but it shows base after you run conda.bat activate, which is not the same thing as running activate. You have ideally you activate base just by executing the command activate.bat, not conda.bat activate. So if activate.bat doesn't work, which looks like it doesn't, right? Like you do activate.bat and press enter, and it doesn't show base if you just do that. Let me open my own demo. Sorting demo. So here we are. This is a Jupyter Notebook, which means it is a mixture of Markdown language and coding language. And you can run each of these guys individually. Right? Oh, it's asking me to select a Python. And it runs. Perfect. So you can do, for example, print and runs C, A. Okay? So cell by cell, you can do anything you like. And Markdown language supports almost everything. It supports LaTeX language, so you can have equations here. Okay, so for example, I can have, let me ask Codex, let me ask chat. Please write an example of an equation in a markdown cell. Please add this, paste this. Oh, it's not changing for me? Huh. Okay, so let me do this then. There it is. This is an equation, okay, in Markdown language. Beautiful, using LaTeX syntax, okay? So, and you can also have figures, you can have diagrams, you can have all sorts of things. So you can have like your model be a combination of concepts with graphs and experimental images. It can be something very, very cool. And you can ultimately launch your Jupyter Notebook online and make it available for other people to use. Okay, let's take a look at what this basic setup is. So instead of using Player and Twedit, we're using Python. So from CC3D, we are importing all the plugins and things we need. So for example, here I'm importing metadata, which allows me to set things like hover, num processors, the number of processors, debug output frequency, and it explains to you a little bit of what they do because the documentation is right here. Pot score. What does pot score do? Oh, it has dimension X, dimension Y, dimension Z. Anneal. You can anneal. I didn't know that. You have fluctuation amplitude that you can set. You can set the boundary condition, no flux, etc., etc. Here are the parameters. Boundary condition, by defaults to no flux. Random seed, lattice type, defaults to Cartesian. I didn't even know there was, the hexagonal is the other one. So it gives you all the options you can set here just by hovering over. All right. We add these specifications to a list, a Python list, specs, and we are appending them. Now cell types. We import the cell type plugin, and then we add cell types, cell A, cell B, and we do specs.append and the cell types plugin with the cell types. What else can I do in cell types? Just give cell types, that's all. Volume constraint, import from CC3D. Then here we are creating an instance of volume plugin, and we use this method param new, which you can see, for example, if you type volume specs. See, it understands the pattern, and it's providing an autocomplete option for me. However, medium doesn't make sense to add volume to medium, so this is incorrect. Okay. If I type a dot, you see there is a param new. That's the method we are using. So if I forget what it is, there is a param new here for us. Okay. How do you specify volume? You define as you say the cell type, and then you give it the target volume and the lambda volume. And then you append your specification to your specs list. And you do the same for contact energies. So here we have medium cell A, medium cell B, cell A, cell A, cell A, cell B, cell B, cell B, with their corresponding energies. This has the neighbor order. Here is where I'm defining the neighbor order too. You can hover over the plugin and you see all the options you can set. You can weight the energy by distance. It's a Boolean, it's a flag, true or false. So you can make your contact energy as you increase the neighbor order have a lesser effect from more distant pixels. And here is how you do it. It's telling you here because it pops open the documentation when you hover over the plugin. Cell distribution initialization. Here I am invoking the blob initializer, and I give it a width, a radius, a center, and the cell types. And I append the specs to my specs list. Then you can define your steppables. This is exactly the same language as we use in normal Python, normal CompuCell3D, so there is nothing interesting here. These are specific for this example, so nothing interesting. Neighbor tracker. You define the neighbor tracker and you append. This is another steppables, so nothing interesting here. Just normal. There is absolutely nothing different. You can copy this and paste in your Twedit and run. Okay. The steppables are exactly the same. This is where it's different. There is this thing, this object or this class called CC3D Sim Service. A CC3D Sim Service is an instance of a simulation. It is the thing that you load the specification, you load steppables, and you initialize, you start, you run, and you finish. This is the CC3D Sim Service. And you can have as many instances of this class as you like. So I can have simulation 1, 2, 3, 4, 5. So I can have 5 simulations running in parallel, for example. You can have these simulations communicating between each other. You're running 2 simulations, 2 instances of the simulation, and you get the cell from simulation A, and you put that cell on simulation B. You can do all sorts of stuff. There is a built-in visualization tool, which for me doesn't work. So, and it crashes everything, so I'm not going to use it. It used to work very well on version 4.6, but something happened in 4.9 that it doesn't work anymore. And all the Jupyter notebooks that I had online for people to launch via link and use, they all crash. So something happened that doesn't work anymore. And unfortunately, we do not have support for Python API anymore because DJ is the guy that used to develop Python API is not very active anymore. So what do? I build my own visualizer using Matplotlib, and this is where I plot my visualizer. Here I am stepping the simulation, so this is the length, the time length of the simulation. And there is this method called step. Oh, I don't know how to step. I say CC3D sim dot, and it gives me all the options. I can visualize, I can step, start, stop, run, init. Here, start, step, stop. There is an attribute called current step, sim name, annotations, all sorts of things that you can see from this drop down. And finally, because of course this is VS Code and this is Python, you have access to all possible imaginable packages. You can import pandas easily in your Jupyter Notebook and plot some cool stuff by the end of the simulation. So here I'm plotting the contact area between cells of certain types. Okay. Any questions on the basic setup of a pure Python simulation? It's not as scary as one would think. Like, it is a little bit scary at first, but it's the same idea as XML. It's just using different syntax. Right? So run this. Let me run this. Let me run this. Run this. Run this. Run this. Run this. You can also just like press shift, hold shift and press enter, and it's going to loop. Visualization is not the, oh, I'm sorry. Let me comment this out. And contact, wait. Not defined. This is not correct. I did define it. Name Steppables, Py not defined. Let me do a restart and run all. Maybe I did something bad somewhere. Run all. I think I did something bad somewhere. Okay, it's running. Oh, right here. Okay. And you can also see that it runs pretty fast. Like each tick of this is 50 Monte Carlo steps for a 100 by 100 simulation. So it's quite fast. It's very good. Now, and then this is the plot. Okay. Now I'm going to show you something very cool. I'm going to send someone a link to this to this workspace. Okay. So I have this extension called Live Share, and I'm going to share read/write. It's starting a collaboration, and I can invite participants. And did it already copy? Yes, I have a link, and I'm going to paste this link in the chat, but just for someone that I want to join. So Clara, if you were there listening to my tedious presentation, feel free to join in. So Clara has VS Code on her end. I have VS Code on my end. And she's going to join via this link. And she will show up here as a participant. So I received a notification. Clara joined the collaboration session, and I can see her here as a participant. Currently, if I scroll up and down, she sees it. But I can do follow participant, and now I'm going to ask Clara to move around, click on stuff, and maybe change some context energies of the code. Am I following Clara? Follow. Is not editing a shared document. Oh, so I didn't share this document? Um, what documents do you have? Ah, data analysis. Okay, I see it. I see it. Data analysis. Okay, there she is. Okay. Now change something. Scroll down, change something. Yeah, I see. I'm not doing anything. She's scrolling. I'm watching her, and she can change something. Yeah, perfect. And maybe she can run, and it shows on her end the result. And I don't even remember what does this do. Yeah, this is a random Python file. It's not the cell sorting. I don't know what happened here that I didn't share this. Shared terminal, shared service. Did I not share this? Ah, this is not in the same workspace. So I didn't share the correct workspace. Okay. Well, so she's there. She can add it to my code. She can run on her end. She can also run on my terminal. Can you try to type something on my terminal, Clara? Hit enter. Here, there is a notification. Make the terminal read write for everyone. If I choose this, she can run stuff on my terminal. So let's see. Depends on which one, because I have many Python terminals open here. Can you type type something on some terminal? Oh, she's pressing enter over here. Can you type something weird and press enter? Hello. There we go. So she typed something, hello, and it says hello is not recognized as the name of something. So basically, she can run my code. She's issuing commands in my terminal. So she can run like the scripts I have and debug them. She can even use her AI tools to change my scripts. It's full access. Yes, it is dangerous. You have to be very careful who you give access to. Yeah, this is really dangerous. Yeah, so I think that's it. I'm going to stop the collaboration session. So thank you, Clara, for the quick demonstration. I hope you guys see some use in these alternative platforms. Of course, they lack some of the functionality we have in Twedit and Player. But there is some very powerful things you can do here because of AI integration, GitHub. I can also show the GitHub stuff. Let me open folder here and go to this guy here. This is my actual project, my virus infection project. And if I click here, source control, it shows the GitHub side of things. And there are some very cool stuff. For example, if I click one of these lines and I hover over this guy here, because I have GitHub, it shows when this change was made and what is the associated commit. And this is the name of my commit, adding simulation files, which is my fault. Okay, not as descriptive, but it's my fault. I can come here and say, oh, this I modified 22 hours ago. This was the previous line. This is the new line. So it's tracking all my changes because it's integrated with GitHub. And I can revert back to a different version. I have all the GitHub tree over here. I can select what files I want to commit. So for example, I want to commit this guy, this guy, this, and this. And let me just make sure I'm not making any mistakes here because this is high stakes. I never remember username in. Am I not logged in? Oh yeah, I am. Whatever. GitHub is always a pain. Okay, so I'm not going to demonstrate things with GitHub, but it is possible I've done. Okay, yesterday I've done it. I don't know why this is failing today. Always a problem. Always, yeah, always. Yeah, I don't know what it is. Make sure you configure your username and in Git. Yeah, whatever. I'll figure that out later. So I hope this was useful. I know some people will end up using Python API to integrate with other tools, and I will be around during the hackathon to help you with that. Also, you know where to find resources. So there is the GitHub page with the demonstrations. We also have the documentation, the CompuCell documentation, which contains some of the Python API functionalities. And feel free to reach out. And I'm going to say thank you. And it's the end. Thank you for attending the workshop. I will see you tomorrow.